In this video, we are going to find top sellers who sold highest number of unique items. Hello, I'm Jagan. I am posting this video to share my knowledge in SQL with you. If this assists you in your interview preparation anyways, I will be happy. First, create the table and then we can talk about the data then and the questions. Okay. We are going to have three tables. First one is users table, second one is the orders table, and third one is the items table. Let's create. Okay. Before you talk about the question, let's go discuss about the table, the structure and the data. Then we can go to the questions in detail. Okay. So here we have three different tables. One is orders table, and then items table, and then users table. Orders table has order ID, date, item ID, and seller ID. Orders table is connected with items table based on the item ID. Okay, if I have the item ID, I can get the item brand. Same way, in the orders table I have seller ID. I can connect to the users table and I can get the user's join date and the user's favorite brand. For example, if I have a data like this, order ID is 1, order date is December 1st, item ID is 4, seller ID is 2. So I get the item ID, I connect to the items table equal to 4 and I get the item brand. Same way for seller ID 2, I connect to the users table and I can get the joining date as December 9 and the seller's favorite brand is Samsung. Okay, so here are the data sets. So we have 8 records. First one is the order ID and then the order date. Third one is the item ID. So if you see 4 as item ID, I connect with the items table. 4 is HP, and the next one is item ID is 2. 2 is Lenovo. Same way I have 1 and 3. And the last column is 2. The stars are just to highlight the numbers. It's not the actual data. Okay, the actual data is 2. 2 is the seller ID. I connect with the users table. So 2, the join date is December 9th and the favorite brand is Samsung. And for seller ID 3, join date is December 19th, favorite brand is LG. Same way we have for sellers 2 and we have 4 and 1. Okay? We have 4 sellers. There's one more thing we have to highlight. We see the last record for item ID, order ID 8, the item ID is 2. 2 is Lenovo and the seller ID is 1. For seller ID 1, his favorite brand is Lenovo. So the item ID and the brand ID matches. So there is a catch in the question. So we just have to remember this. Okay. So that's how the item brand and the seller's favorite brands are connected based on the item table and the user table. Okay. Now let's go to the question. The question we discussed is, we are given the 3 set of tables. Now we have to find the top sellers who sold the highest number of unique items, the different brands than their favorite brands. If the seller's favorite brand is same like the brand he sold, then we are going to ignore those. That's why I highlighted the last record. If there are more than one sellers, then we have to bring in all those top sellers. Okay, so we discuss about bringing in like the employees who had top salary, more than one employee, then bring all the employees kind of video, right? First or second video. So you can just revisit those videos for more details. Okay, now let's start the SQL. So what are the tables we have? Let's list down the tables. So the first one is users, second one is orders, and the third one is items. So what are all the main points we have to remember? mainly 4 things. How the items are connected between order and the item table, and then how the seller ID are connected between the order and the users table. Third one is the favorite brands, it's in the users table, and how the item brand and the favorite brands are connected. Okay, these are the key things we have to remember. Now let's start the SQL. Let's connect between the tables. We take order table as the key table. Okay, so we take the orders table and then we connect with items table and the users table. Okay, so select, we can do the select thing later. From orders, which is O, inner join items I, it's connected with item ID. Item ID equal to order dot item ID, and then inner join users u on u dot seller ID equal to order dot seller ID. Here we are doing all inner join with the assumption that if there is any item in the order table, it should be there in the items table. Same way, if the order ID is having seller ID, that seller must be in the user table. That's why we are going for inner join. We are not going for the left joins now. Okay, now see how the data looks. Okay, order dot seller ID, I can see the brands, right? Item dot item brand, right? So just want to make sure the column names are right. So item dot item brand, and then third one is user dot favorite brand. Okay, and then we are going to see count of, they say, unique items, highest number of unique items. That means count of distinct O dot item ID as total items. Okay, let's run and see how the data looks. Okay, since we use aggregate function, we just add group by 1, 2 and 3. Okay, so if we see seller ID 1, he sold Lenovo and LG, and the Lenovo is his favorite brand. For seller number 2, he sold HP and Samsung, and his favorite is Samsung. And for seller 3, the item brand and the favorite is not matching here. Okay, LG and LG is matching, and for 4 there is no match. So we are going to consider 2 items for seller 4 and 2 items for seller 3 and 1 for seller 2 and 1 for seller 1. Okay, so now what we are going to do is we are taking the extra condition and then say and item brand is not equal to the favorite brand. Okay, so it brings in 4 users and their unique item IDs they sold. Now I have to get only the last 2 because those 2 sellers are the one who got the highest number of unique items, just 2. So we can just use this as a CTC table, all sales as this. We just say select a dot seller ID a dot total items from all sales. So this will give all the sellers and total items, and the condition is where, you see alias name, right? a dot total items, it's the maximum of the total items. Select max of total items from all sales. So the total items must match with the maximum of the total items. Now it filter out only the 2 sellers who got the maximum items, right? So this condition you can play around with it. Instead of doing a where condition, I can just do another inner join, and I can use this subquery directly as a subtable. Query b on b dot total items equal to a dot total. So when you do a table like this, better you have the alias name. Okay, so instead of a where condition and a subquery, we are just doing that as a table itself. Okay. Okay, so this is a simple straightforward question. So how can we use a Windows function? Okay, we talked about the rank and the dense rank in our initial videos, like first or second video, right? We are going to do the same exercise. We are going to have the SQL as such before, and then let's see how the rank and the dense rank works. Okay, dense rank. So here we don't have a partition, right? We have to get the maximum of all the sales. So we say order by total items, and it should be the descending order, right? As rank. Same goes with the dense rank. Let's see what's the difference between the rank and the dense rank here. So if you see the rank, the first two are the top, right? So rank 1, and he skips the 2, goes to 3, and 3 and 3, next is going to be 5, right? There won't be any 4. So 2 and 4 are missing. When you do a dense rank, the sequence will be maintained. Since you are going to get only the first top rank, we don't have to worry about rank or dense rank. But if you want to get the top 3 or top 4, then we have to go for the dense rank. So preferably I'll take the dense rank. Okay. So here, if I use a Windows function, one of the bottleneck is we have to add one more SQL on top of it. Select a dot sales ID item from, just create this as a table where dense rank equal to 1, right? So we can use this as another subquery, and we create this, or you can create another CTC table like top sales as. We can just have this and then just use that CTC table here from top sales where dense rank equal to 1, right? There are many ways to address this question. If the database like Teradata, they have one more feature, which is the qualify function. We don't have to do two CTC table. We just say this, and then we say qualify this Windows function equal to 1, right? This is not going to work for MySQL or what's the other database we have here, Postgres, right? So we don't have Snowflake or Teradata as a sample. So if you have those databases, you can just use a qualify function, and we can filter the Windows function directly in the where condition. Okay, so instead of where, we just say qualify. So this should work with Teradata and Snowflake, but not with MySQL or Postgres. Okay. Yeah, hope this helps. Thank you.